Yeah, myself, B. Suresh, lecturer in Mechanical Engineering, Government Polytechnic, Chegunta. So I am going to take a subject called Basic Workshop Technology. So these are the objectives. On completion of this class or period, you would able to know what is carpentry, identify various carpentry tools, identify marking and measuring tools used in carpentry, explain the construction of these tools, state the specifications of these tools, state the use of these tools. Okay. So carpentry. Have you ever seen manufacturing of doors, windows, wooden furniture, etc.? Can you name the name of the manufacturing process used? The manufacturing process is called a carpentry. Okay, right. In this lesson, we will learn some basic concepts of carpentry. So first of all, so these are this is a figure. Okay, this is a figure from carpentry workshop. Here they are doing some work. They are preparing some wood components. So actually, what is carpentry? So it is the process of wood to obtain desired shapes and sizes of goods and components like doors, windows, roofs, etc. So actually, carpentry is the process of woodwork to obtain the desired shape and sizes to get a desired article or a component. So some of the examples are doors, windows, roofs, cupboards, etc. The tools used in the woodworking process are known as carpentry tools. So whatever the tools we are using in woodworking process, okay, so those tools are called carpentry tools. So there are some of the carpenter tools. Okay, so first one is marking tools and measuring tools. Number two, cutting tools. Three, boring tools. Four, striking tools. And five, holding devices. And the sixth one is miscellaneous tools. Okay, so while coming to marking and measuring tools. Okay, so these tools are used for marking and measuring. Okay, marking, measuring, and checking the work at various stages. Okay, so some of the marking tools. Okay, we are going to discuss now. So pencils and pencil compass. So these are the different types of pencils we are using in carpentry. So H, 2H, HB, etc. are used for making dimensions and contours on woodwork. So there are different types of pencils used for marking dimensions and contours on the wooden workpiece. Okay, so special bigger size compass is used for drawing circles. So special size compass is used to draw the larger circles. Okay, to draw the circles of 25 mm to 500 mm. Okay, so carpenter's folding rule. So there is a folding rule. Okay, to measure or to draw some dimensions. Okay, right. So it is a foldable wooden scale used for measuring and setting out dimensions up to 600 mm. So it is a carpenter's folding rule is a foldable wooden scale. So and it is used for measuring and setting out dimensions up to 600 mm. So it consists of four pieces. This carpenter's folding rule consists of four pieces. Each is 6 inch or 150 mm, joined together by means of long pins and inks. Okay, by means of long pins and inks. So each 6 inch uh, piece is joined by the long pins and hinges. So it can be folded to a single piece length. So by folding all four pieces, so it can be folded to a single piece length. So you can see the diagram of four folding rule. Four folding rule. So it consists of some graduations. These are in centimeters as well as in inches. So this is made up of wood. Okay, you can see the diagram. So it is a four folding rule. Okay. So next one is steel tape. Okay. So this is a diagram of steel tape. So steel tape is used for measuring longer dimensions. Okay. So if you want to measure the longer dimensions, so with the help of steel tape, so we can measure the lengths for longer distance and longer lengths. So the steel tape is a flexible and can be coiled or rolled in a case. So within a case, so this steel tape is folded or coiled. Okay, so it is a flexible steel tape. So it ranges from 0.6 meters to 2.5 meters. That is the range of the steel tape. So we can see the diagram here. Steel tape or steel rule. Steel rule. This is a diagram of a steel rule. Okay, right. So steel rule is used for measuring and setting out linear dimensions. If you want to measure and setting out linear dimensions, so with the help of this tool, steel rule, so can measure and draw the markings on the wooden workpiece. So to an accuracy of 0.5 millimeters. So it consists of some graduations. So these are in inches, and this side we have it in centimeters. Yeah, steel rule is made of stainless steel. So it is made up of a stainless steel and graduated in inches and centimeters. Just now I told. So these tool rules are available in different lengths, ranges from 150 mm to 600 mm. So these steel rules are available in different length of ranges. So they are from 150 mm to 600 mm. Next one is straight edge. Okay, so you can see the diagram of straight edge. This is a diagram of a straight edge. So this is a straight edge. Okay, and this will be the usage of the straight edge. So this is a workpiece. This will be the straight edge. So with the help of a scriber, so he is going to give a dimensions or mark the dimensions on the wooden workpiece. Right. So straight edge is used for testing trueness of surface and edges. So this straight edge is used for testing trueness of the surface of the workpiece and edges. So it is a flat piece of wood. So straight edge is a flat piece of wood. So it is made up of a wood or a metal and has truly straight and parallel edges. So it has truly straight and parallel edges. So next one is a tri-square. Okay, a tri-square. So this is a diagram of a tri-square. You can see the diagram. So So it consists of blade and stock. Okay, the blade is fixed to the stock at one end at an angle of 90 degrees. You can see here an angle of 90 degrees. Okay, this will be the usage of the tri square, and this part is called work or job, and this will be the steel rope, right? So tri square, sorry, this will be the tri square, not steel rope. So tri square is used for testing flatness of surface. So this tri square is used to test the flatness of the wooden workpiece, and also the marking parallel lines. So we can also draw the parallel lines with the help of a tri square, and also marking and testing at right angles. So if you want to test the workpiece at right angles, so with the help of tri square you can also test the right angle triangle. Okay, that it is with the flat or not. You can check test the workpiece by the tri square. So these tri squares are available. Size of blades ranges from 100 mm to 300 mm. The size of the blade ranges. This is the blade size. So this is the blade. The blade size ranges, okay, available from 100 mm to 300 mm. So that is the tri square. You can see the diagram here. This will be the blade, and this part is called stock. Yeah, usage of tri square on the workpiece. So with the help of engineer scriber, he is going to mark or draw dimensions or lines on the wooden workpiece. So by the tri square, you can observe the movement of the scriber. Next one is bevel square. So you can see the diagram of a bevel square. Okay, right. So it is also called sliding level. Sorry, sliding level. And this bevel square is used for marking and testing of many any angles between 0 to 180 degrees. So with the help of this bevel square, so we can mark and test the surface at an angle between 0 to 180 degrees. So it has slotted blade and stock. So this will be the slotted blade. This will be the stock. Okay, and can be set any position with a screw. So with the help of this screw, we can set the slotted blade at any position. So you can see here stock and sliding blade. You can see the diagram. So next is metric square. Meter square. So we can see the diagram of a meter square. Okay, right. So meter square is used for marking and testing 45 degrees. Okay, so it is used for marking and testing the surface of the workpiece at an angle of 45 degrees. So blade is fitted to stock. So this is a blade which is fitted to the stock at an angle of 45 degrees. So this blade range available in size 150 mm to 300 mm. Next one is combination square. So this will be the diagram of a combination square. You can observe the diagram. There are some graduations on the combination square scale and the locking screw, spirit level, square head. You can see some of the parts also. Bevel protractor, that is bevel protractor head, vernier scale, center head. You can see the diagram. Right. So this combination square, it is a useful tool and consists of square, bevel square, and center square head and a rule. So this is a useful tool. So it consists of square, bevel square protractor head, center square head, and also a graduated rule. And it is useful for checking angles. It is also useful for checking angles. So find out the trueness of the surface and also the marking centers on end of the round jobs. Okay, this is the actual diagram of a combination square. So next one is marking tools. So here we have some of the marking tools. Okay, right. So first one is marking gauge. So this is a diagram of a marking gauge. You can see here. So this will be the marking device, a marking gauge. This is usage of the marking gauge. Okay. So this marking gauge has consists of stock. This part is called stock, and this will be the stem and the thumb screw, and this black color is called marking pin. Okay. So marking gauge is used for cutting parallel lines. So this marking gauge is used for cutting parallel lines along the grains at a given distance edge from an edge. So from the edge of the, if you want to draw the parallel lines on the workpiece, so with the help of a marking gauge, you can draw the parallel lines along the grains at a distance from an edge. Okay. So it has a stem with a sharp pin. So this will be the stem with a sharp pin at one end. So the distance can be adjusted by sliding the head on the stem or stalk on the stem. We can also adjust the sliding and adjust the stalk on the stem or head. So this is the actual diagram of a marking gauge. Yeah. So this is a screw pin, and this will be the stem, and this part is called brass strip, stalk, thumb screw, and alternate cutting gauge. This will be the alternative cutting gauge. So this is a diagram of marking gauge. So tightening thumb screw, loosen thumb screw. Yeah, see the diagram and the usage of the marking gauge. If you want to draw the parallel lines, if you want to cut into a parallel line, so we can cut the parallel lines. We can cut the work into a parallel to draw the parallel lines. So this will be the starting point. From starting point we can draw a, we can cut the line on the marked. So you can see the diagram here. So this is also a marking tool. So it is a mortise gauge. Okay, and this mortise gauge is used for cutting two parallel lines in a single stroke. So within a single stroke, the stroke of the movement of the mortise gauge, you can draw the or you can cut the two parallel lines. So it has two sharp pins. So these are the two sharp pins. So one is movable, another is fixed. So you can see the diagram here. You have mortise gauge T519 mortise gauge. You can see here fixed screw, that is fixed pin, sharp fixed pin, and adjustable screw pin. So this will be the mortise chisel. Here you can see the different parts of mortise gauges. Mortise gauge: stem, nut, thumb screw or brass, stock, set screw, adjustable screw, fixed screw. See the usage of mortise gauge. So next one is panel gauge. This is a diagram of a panel gauge. So it is also similar to the marking gauge. It has a long stem. So as compared to the marking gauge, so the length of the stem is longer, okay, for this one. So which enables to mark the whiteboards like door panels. If you want to mark on the whiteboards, so with the help of this panel gauge, can mark the lines on the door panels. So next one is marking knife. So this will be the diagram of a marking knife and the usage of the marking knife on a workpiece with the help of a tri-square. So this marking knife is used for converting pencil lines into cut lines. So before going to use the marking knife, so we have to prepare the workpiece and we have to draw the marking lines with the help of a pencil. So after if you want to cut the lines on the pencil lines, so we can also we will use marking knife. Okay, that is so used for converting pencil lines into cut lines. So this marking knife here has a chisel edge. So this will be the chisel edge at one end and the sharp point. This will be the sharp point at the other end. So it is known as a scriber. So also known as scriber. So you can see the marking knives. So see the usage as marking knife on the workpiece. So cutting lines on the pencil lines. So next is measuring tools. So there are some of the measuring tools. So among them are calipers. So calipers are used for measuring the size of workpiece. So these calipers are used to measure the size of the workpiece and transfer the same to the steel rule to read. Okay. So with the help of this measuring tool or measuring instrument, so we are transferring the same to the steel rule to read the measures. So it has two legs. So calipers has two legs hinged together at one end. So it has two legs, but it is hinged at one end. The size of the caliper is the maximum distance that can be opened between legs. So based on the stretch of the legs, okay, or opening of the legs, so the size of the caliper is determined or fixed. So based on the type of joint, so there are two type calipers. So based on the type of joint, there are two type of calipers. So first one is firm joint caliper, second spring joint caliper. Okay. So now this is the diagram of a outside caliper. So we can see the diagram here. So it is a diagram of a outside caliper, right? So outside calipers. So legs bend inward. So we can see here. So this is the one leg, then this is second leg. So here also this will be the first leg and this will be the second leg. These legs are bend inward for measuring outside dimensions of the cylinders. So by bending the inward of the legs of the caliper, so we can measure the outside dimensions of the cylinders or thickness of the plates, etc. So this we can see here. So outside calipers. So this will be the firm outside caliper. This will be the spring type outside caliper. Okay, this is also spring type outside caliper, right? So outside calipers measurement. We can see here. You can see the diagram here. Outside caliper measurements. Okay. So next is inside calipers. So this first diagram is in this diagram. This will be the form joint inside caliper, and this will be the spring type inside caliper. So we can use both. Okay, to find out the diameter of the hole. Okay, right. So the legs are bent outward. So in previous cases, the legs are bent inward, but here the legs are bent outwards and is used for measuring diameters of holes, width of keyways and races. Okay. Next, you can see the diagrams here. Inside calipers. So you can see here. So he is finding the diameter of a hole. Okay, he is finding the length distance between these two components. Right. So next one is divider. Okay, this is a diagram of a divider. Okay, and this divider is used for transferring the measurements from rule to wooden surface. Okay, and this is used for transferring the measurements. So with the help of this divider, we are transferring the measurements from steel rule to the wooden surface, and it is used for scribing circles, arcs. So it has two legs. So these are the two legs and can be set by a set screw and a nut against the circular spring. This will be the circular spring against the circular spring. So screw and nut will be set. You can see the diagrams here. Next, so it has two legs and can be set by screw. Okay, already I told. So next, you can see the diagrams here, divider diagrams. So these are the two legs. Here are the two legs. So, but two legs are in different sizes and shapes in different way. Yeah. Next one is wing compass. Wing compass. You can see the diagram of a wing compass. Okay, and this is used for marking equal divisions. If you want to draw equal divisions on the workpiece, with the help of this wing compass, we can draw the or we can mark the equal divisions, scribing circles and arcs on the wooden workpiece. So it is made up of steel. So this wing compass is made up of steel. It also consists of a two pointed legs. So these are the two pointed legs. And the legs can be secured in position. These legs can be secured in position by means of a set screw and a quadrant. This will be the set screw and the quadrant. So next one is this is also wing compass. You can see here. So next one is trammel. Okay. So it and trammel is used for drawing large circuits. So with the help of this trammel, so we are going to draw the larger circles and arcs. So beyond the scope of the compass. So beyond the scope of the normal compass. So whatever the circles you are not able to draw with the help of normal compass, that such large circles are can be drawn with the help of trammels. So it has two pins. So it has two pins on two sliding heads. So you can see here. So these are the sliding heads. So it has two screw pins. This is a screw pin and this is also a screw pin. Okay. So it has two pins on two sliding heads on wooden beam. And the distance between two points can be adjusted with thumb screw or ring screw. So with the help of ring screw or thumb screw, the distance between these two heads can be adjusted. Okay, you can see here. So with the help of this term, you can draw the large circles. Next, spirit level. So this is a diagram of a spirit level. You can see here. Yeah. And this is used for testing the horizontal levels. So we want to find out the horizontal levels on the surface. Okay, and this can be used. Okay, and setting surface parallel. Next, next one is plumb bob. This is a diagram of a plumb bob. So it is used for testing the vertical surfaces. Okay, if you want to find out the testing of vertical surface, so with the help of plumb bob, so you can find the testing of the vertical surface on the workpiece. And now we are going to discuss about the cutting tools. So what are the cutting tools used in carpentry? So we are going to discuss now. So they are the cutting tools like saws, chisels, planes, okay, and their specifications and the uses. So uses of these three cutting tools. Okay, so these are the cutting tools used in carpentry. So cutting tools are used to cut the wood to appropriate size or to cut the excess wood to get desired shape, size and accuracy. So why we are using these cutting tools are cutting tools means so if you want to cut the wooden work with the appropriate size. So we are preferring for the cutting tools. Suppose if you want to remove the excess woodwork from the workpiece to get your desired shape, size and accuracy. So we are using these cutting tools. Okay. Next, cutting tools are classified as saws, chisels, axles, planes. Okay, so saws are hand saw, saw or hand saw. You can see the diagram of a hand saw here. Okay, heel, toe, okay, back. You can see here. Right. So saw is used for cutting the wood to obtain desired shape and size. If you want to to obtain a desired shape and size, so with the help of a saw or a hand saw, so we are cutting the wood to a desired shape and size. So the parts of hand saw are wooden handle. This will be the wooden handle. Okay, this is the wooden handle. Blade carries cutting teeth. This will be the blade, so which having the cutting teeth on the front. So you can see this will be the blade having a cutting teeth here. Okay, this will be the blade. Next, saw teeth settings. Okay, saw teeth settings. All the cutting teeth are set to the right and left of the blade. Okay, so how we are setting the teeth on the saw means saw setting teeth are, so all the cutting teeth are set to be either right and left of the blade alternatively to make the width of cut wider and to move smoothly across the wood. Okay, that's why it is so the cutting teeth are set to the right and left of the blade alternatively. Next, specification of a saw. So hand saw is specified by length of the blade. Okay, that is varies from 600 to 700 mm. That is the length of the blade varies. Next, pitch of the teeth. Okay, so pitch of the teeth is about 2.5 to 8 mm. Next, there are different types of hand saws. So we can see here. First one is rip saw. Second one is cross cut saw. Okay, and panel saw, tenon saw, dovetail saw, bow saw, coping saw, compass. Okay, and pad or keyhole saw. Okay, you can see the diagram here. So uses of a rip saw. Okay, this is the rip saw teeth settings. You can see here. Okay, rip saw teeth settings. The root angle is about 20 degrees, and the distance uh, between these two teeth, that is angle, is about 60 degrees. So you can use, right. So ripsaw is used for cutting the wood along the grains. So ripsaw is used for cutting the wood along the grains, and this cutting process is called ripping. So when the wood is cutting along the grains, okay, so this cutting process is called ripping. Okay, so its teeth have chisel edge. Okay, the teeth have chisel edge. The pitch of the teeth, that is 5 to 8 mm. Okay, for this ripsaw, and length of the blade is about 700 mm. Next one is cross cut saw. You can see here, cross cut saw. And this cross cut saw is used for cutting the wood across the grains. So previously, cutting the wood along the grains, that is in ripsaw. So in cross cut saw, we are cutting the wood across the grains. Okay. Next, the teeth are pointed. So how the teeth are? They are pointed. The pitch of the teeth is about 2.5 to 3 mm. Okay, that is a pitch range. and 3 to 4 teeth per centimeter. Per centimeter, 3 to 4 teeth have. Next, length of the blade is about 600 mm. That will be the available range of the blade. So next one is panel saw. So this is a panel saw. You can see here. So it is used. So it is a commonly used hand saw. Panel saw is a commonly used hand saw. So it is almost similar to the crosscut saw. Okay, and used for finer works. So this is used for finer works like door panels. Okay, if you want to prepare door panels, so with the help of this uh, panel saw, so we can cut the wood. Okay, that is finer works. Next, plywood sawing and used for cutting along the grains as well as the across the grains. This panel saw is used for along the grains and also for across the grains. The pitch of the teeth is about 2 to 2.5 mm. That is the pitch of the, between the two teeth, and 5 to 8 per centimeters. 5 to 8 teeth per centimeter. Next, length of the blade is about 700 mm. Okay, next one is tenon saw. You can see the diagram of a tenon saw here. So this is a diagram of a tenon saw. So blade has brass. This is a blade made up of brass or steel back. So reinforcement which protects from bending during straight cut. Okay. So whenever you are performing the straight cuts on the workpiece, okay. So this can be used. Okay. So then this tenon saw is used for cutting small works like joints. So this tenon saw is for cutting small works like joints. So length of the blade is about 250 to 400 mm. So the length of the blade is about 250 to 400 mm. This will be the width of the blade. This is the width of the blade, that is 60 to 100 mm and 6 to 8 mm. Next is dovetail saw. So we can see the diagram of a dovetail saw. So it is a brass bag metal. You can see the diagram here. Okay. So it is also similar to the tenon saw, but size is small. Okay, but size of the saw is small. So blade is fitted to open handle. So this is the blade which is fitted to the open handle. Okay, you can see here, and it used for finer works like tongs for dovetail joints and cabinet works. Okay, next length of the blade is about 200 to 300 mm. So pitch of the blade is about 1.25 to 1.75 mm and 6 teeth per centimeter. Per centimeter, so there are 6 teeth in the dovetail saw. So next one is bow saw. So this is a diagram of a bow saw. And this will be the blade. Okay, and this bow saw is used for cutting curves, profiles, or irregular shapes. So this is used for cutting the curves, profiles, or irregular shapes. Okay, the blade is connected between two handles. This is the blade It is connected between the two handles of wooden frame. This is a wooden frame. So between the two handles, the blade is connected or fitted. So tension to the blade. Tension to the blade is provided by the twisting the string. So by twisting the string, so we can provide the tension to the blade. So with a lever, okay, with a lever at the upper end of the frame. This will be the upper end of the frame. There is a lever. So with this, we can provide the twisting to the string, so that we can provide the tension to the blade. Next, length of the blade is about 300 mm and pitch of teeth is about 2.5 mm. Okay. Next one is coping saw. This is the coping saw, and this is used for cutting excess wood, small curves to make dovetail joints. If you want to produce dovetail joints on the wooden workpiece, so we have to remove the excess wood from the workpiece, and also we can draw the small curves with the help of coping saw. Next, the blade has a small pin. This blade has small pin on each end. So for both the ends, there are small pin, so which fits into the slotted lugs in the frame. This will be the frame. So it has two lugs. So within the lugs, the blade will fitted. The tension to the blade is adjusted by the screwed handle. So this will be the screwed handle. The tension is the tension to the blade is adjusted. Okay, the help of a screwed handle. So blade length is about 160 mm, width is about 3 mm, pitch of the teeth that is 1.5 mm to 1.75 mm. Okay, next keyhole saw. Okay, so this next one is keyhole saw. So this is the smallest saw and used for internal intricate works and keyholes. So this will be the smallest saw, and this is used for producing internal intricate works and also keyholes. Okay, next tapered blade fitted to metallic or wooden handle. This will be the metallic or wooden handle. A tapered blade is fitted to this one. Okay, by means of a screw. Next, handle is made hollow from inside. This is a handle is made hollow from inside, and the length of the blade is can be adjusted. Okay, length of the blade can be adjusted. So length of the blade is about 150 mm to 200 mm, and the width 6 mm near handle and 3 mm at tip. So here there will be 3 mm at tip and 6 mm at the near handle. Next, pitch of teeth is about 2.5 mm. Okay. So next one is compass saw. You can see here compass saw. So, and this is used for cutting st- straight or curved in a limited space, outside or inside the wood. Okay, so this is used for cutting the straight or curved within the limited space, so either outside or inside of the wood. Okay, for internal cutting, a hole is drilled first. For if you want to produce if you want to cut internally on the workpiece, first of all you have to drill hole on the workpiece, and then the blade is inserted into it. So then after the compass saw is inserted, that is the blade of the compass saw is inserted into the hole. Next, the blade is fitted to open handle. This is a blade which is fitted to the open handle. Okay, the length of the blade is about 250 to 400 meters, and the width that is 50 mm at the handle. Okay, and 25 mm at the tip. Okay, so this from here I will stop today.